Hi everyone, and welcome back to another episode of Science. In this episode, I want to teach you all about heat transfer. So I'm not covering transformation in this lesson. If you're not sure what transformation is, you probably want to have a look at Energy Part 1, the video I uploaded before this one, just so you can catch up on what the difference is between transfer and transform. Transfer is energy moving from one place to another or one object to another, and transform is when you change the type of energy. So heat could be transformed into light as an example. But in this particular video, I'm just focusing on heat transfer. Okay, so let's start with some definitions, some notes that you can begin with. Heat is energy in transit from an object or substance to another object or substance with a lower temperature. Heat can move from one place to another in three different ways. So today I'm going to teach you about conduction, convection, or radiation. Let's start with conduction and these two examples I've got on this slide. Some of us might have accidentally touched a hot stove or a hot piece of metal, maybe something you've just pulled out of the oven. In this case, the hot stove, because it is hotter, it's transferring its heat into your hand. And you can feel hot stuff by thermoreceptors that are found within your skin. You've got specific receptors that can feel heat. Now, when you touch something really hot and your skin burns, that heat has damaged your skin, has killed some cells, damaged some cells, and the way that you heal from a burn is new skin cells growing to replace the damaged ones. So in this case, heat is being transferred into your hand, and if you've touched something really hot, you may get a burn, and that burn is because the heat has damaged your skin cells. On the right hand side here, the opposite is occurring. Your hand is actually much warmer than the ice cube, and you've probably felt that before as well. In this case, the heat from your hand is transferring into the ice block. And we can feel it within our hand. We can feel how cold that ice block is, and we can also see it melting. The reason why the ice block feels so cold is because it's sucking the heat away from your hand. It's drawing the heat out of your hand and into the ice block. And so that's why it feels cold. If you touch two different objects in the room that you may be in, everything that you touch around you will be room temperature. It will be the same temperature. But one thing may feel cooler than the other. So for example, if you picked up, a book, for example, versus if you grabbed the leg of your table. The leg of your table, if it's made out of metal, might feel colder than the book that you're holding in your hand. Now that metal and the book is actually the same temperature. They're both at room temperature. But the metal might feel colder in your hand because the metal is much better at sucking out the energy from your hand, sucking out the heat from your hand compared to the book. Why is that? Metals are conductors. They're good conductors of heat and electricity as well. So because metal is a good conductor, metal is very efficient in sucking out the heat from your hand. So it feels cooler. Whereas a book, it's not a very, very good conductor of heat. And so the book is not very good at sucking heat from your hand. And that is the reason why, as you're holding a metal leg of your table versus the book in your other hand, the metal is much more efficient in drawing out the heat compared to the book. But if you had like a laser thermometer or something like that, it would show that the metal leg of the table and the book is actually the same temperature. They'll both be at the room temperature that you're sitting in. Pretty cool. Let's take a step forward here, and I'll go into more specifics about conduction now. So let's start with a definition. Conduction. A method of heat transfer in which heat is passed by the vibration of particles. Metals are good conductors of heat because their atoms are close together and arranged neatly in a lattice, or in other words, like a grid structure. So here I've got a metal rod, and underneath I've got a Bunsen burner flame. Now this heat energy is being transferred into the metal rod, and that metal rod is made out of metal atoms. When you introduce heat to atoms, they start to jiggle around and vibrate more, and the jiggle of one atom gets passed to another. So here I'm converting heat energy into kinetic energy. The atoms are vibrating more and more. The more I heat it up, the more they jiggle and vibrate. And as this atom vibrates, it knocks the next one, and then the next one, and the next one. And so you have kinetic energy being transferred, kinetic energy of the atoms being transferred from one atom to another. And so that's why a metal rod can be heated up, even though if the flame is just in one location. It's because the heat gets transferred into the atoms vibrate, and they pass on that vibration down the rod in all directions. Pretty cool. So conduction is the transfer of heat by touching. In order for this metal rod to transfer its energy into you, you have to touch it, you have to hold it. So conduction is dependent on a touch. The atoms need to be touching together. This example here is a good one. So if you stick a metal rod into a flame, that flame is transferring its heat into the metal rod. And that heat is moving up the metal rod via conduction. And because you're holding onto the metal rod, the heat of the metal rod moves into your hand via conduction. Now, after you've paused the video and taken notes here, and you can even draw a diagram to help you understand the notes, I want you to watch this video, Misconceptions About Temperature by Veritasium. Really cool video, and it explains what I was trying to explain on the slide before, about how the things around you are actually the same temperature, but they feel different because of how conductive they are. Really, really cool. So I recommend that you watch this after you've taken down some notes and drawn some diagrams. If you still don't understand after looking at this, come and talk to me in class. Okay, let's take a step forward. The next one is convection. So convection is the transfer of heat in a liquid or gas due to less dense, warmer matter or atoms rising and denser, cooler matter falling. And there's various scenarios where convection currents are created. So under the Earth's surface, the Earth's core is very, very hot. And that makes the warmer rocks, I suppose I could simply say, the warmer magma, rise to the top. And as it cools, it falls back down to be warmed up again. And so you create these cool convection currents. The heaters within your homes, warm air rises, and as it cools, it falls back down to the ground. And then it will be warmed up again by the heater, and you can get a convection current forming in your house or in your room. If you've ever been in a two-story home, you might have noticed that the second story is warmer than the first story. And that's because warm air rises. Warm air is less dense, meaning the atoms are more spaced apart from each other, and so they rise. And then as the air cools, the atoms move closer together, and therefore the air becomes more dense as it cools, and then it falls back towards the ground. When you're cooking something in a pot, say you've got a pot full of water and you've got some pasta in there or something like that, the hot water molecules at the bottom of the pot rise to the top, and as they cool, they fall back down to be reheated by the fire that's underneath them. So when you're cooking within a pot, you also form convection currents. Pretty cool. So once again, please pause the video here and take down any notes that you need to, and also use diagrams to help your understanding as well. If you didn't understand what convection is, come and talk to me in class or watch a couple of more YouTube videos. Okay, the final form of heat transfer, and this one is called radiation. Radiation. Okay, let's start with our definition. Radiation is the movement of heat in the form of electromagnetic waves, which can travel through a vacuum. So you cannot form a convection current in a vacuum. Convection currents need atoms to be moving around. Compared to radiation, though, radiation can travel through a vacuum, can travel through space. And we experience this on our skin as we go outside and you can feel the sun warming your skin. That's the heat, the radiation of the sun that you're feeling. It's generated within the sun itself through nuclear fusion, and that heat, that energy, travels through space until it reaches Earth and touches your skin. You can also see some of that electromagnetic waves. Right? Some of the radiation you can see with your eyeballs in the form of visible light. The heat, the infrared that the sun produces, you can feel on your skin. Now, some of the electromagnetic spectrum is harmful to us. So, for example, ultraviolet light is also released by the sun. That arrives on Earth and it can burn our skin. So the sun produces lots and lots of different kinds of radiation, lots of different kinds of light. And this light, the scientific term, we call electromagnetic waves, or the electromagnetic spectrum. So X-rays, for example, that's on the electromagnetic spectrum. Gamma rays, ultraviolet rays, visible light, infrared, radio, all those things are examples of radiation or examples of light. Sometimes you use different terminology depending on what context you're speaking about. The infrared radiation we feel on our skin. The visible light radiation we can see with our eyeballs. If you've never seen the electromagnetic spectrum, I would highly recommend that you Google it or watch a YouTube video on the electromagnetic spectrum. Very cool. But just to sum up, radiation is heat, energy that can travel through a vacuum. And the heat energy that we feel from the sun is infrared energy, and our thermoreceptors in our skin can sense that infrared energy from the sun. Okay, and I think that pretty much wraps up our lesson. Once again, if you're not too sure, do a little bit more YouTubing, a little bit more Googling, come and talk to me in class, and make sure that your notes are up to date with everything that I'm teaching. Thank you for joining me on this episode of Science, and I will see you on the next one.